Okay, let's look at systems of masses. What if you have a bunch of masses connected, for instance, with a string? Okay, this is an Atwood machine. It's just a simple, massless, frictionless pulley with two masses, one hanging off each side. What's going to happen when I let this go? Or if I give it a push? We can do a thought experiment where we look at the extremes. For instance, if these were equal masses, the force of gravity on either side would be the same, and we might expect that this would be in equilibrium because there's no net force turning it one way or the other.
Okay, let it go.
The other extreme might be if one of these masses was infinitely greater than the other. So this was huge or this was zero, in which case there would be no force here, and this would accelerate just like gravity, just like this wasn't here. So it's reasonable to say this should accelerate somewhere between 0 and gravitational acceleration. And so what if one is a little bit bigger than the other? Does it accelerate like gravity, or does it accelerate less than gravity? And what does it depend on? So before we look into this, let's consider what's going on at the wheel. What do we know about T1 and T2? In most of our problems, we're going to say that the tension along a string is always the same. That the tension pulling this mass upward is the same as the tension pulling the wheel down, which is the same as the tension pulling the wheel down from this side, which is the same as the tension pulling the mass upward here. Why can we say that? Well, if we look at a chunk of string, let's say there's some tension on the right side and there's some tension on the left side. What if they weren't equal? What if they weren't equal and there was this chunk of string here, and then we would say, let's say tension right was greater than tension left. Then there's a net force. The vector sum of the forces is equal to the mass of the string times the acceleration of the string. And so this difference in tension would accelerate the string in that direction. Now if we say that it's a massless string, then no matter what the acceleration, the forces on it have to sum to 0, and these must be the same. We say the same about the wheel. What if we were pulling harder on one side? What if tension 2 was greater than tension 1? This would tend to make the wheel spin faster and faster in this direction. But if we say that there's no friction and there's no mass of the wheel, then no matter what the acceleration, there would be no difference in tension. And so that's why you always hear physicists say a system of pulleys with mass equal to 0 and friction equals 0. And so this is an idealized system. No wheels are massless or frictionless, but it simplifies a problem for us to be able to use it. Later we can always add friction and add mass.